An LFO, or low-frequency oscillator, is a fundamental component in modular synthesis and electronic music production. In the context of modular music, where various modules and different functions are interconnected to create sounds, an LFO plays a crucial role in shaping and modulating these sounds. Unlike regular oscillators that generate audio rate frequencies, usually in the range of 20 Hz to 20 kHz, LFOs operate at lower frequencies, typically below 20 Hz. This frequency range is not audible itself, but is perfect for modulating other parameters. The best way I can explain an LFO is like it's a number going from 0 to 1 over time. It goes to 0, 0.1, 0.2, 0.3, all the way up to 1 in the space of whatever time you want it to. Here's a visual representation of what that looks like, although with many more decimals than my example to create a smooth curve over time. Here you can see a simple sine wave LFO. Sine waves are often seen as a smooth curve, however if we wanted to make a more abrupt curve, we could use a triangle wave. This wave itself is self-explanatory, it's sort of between a sine wave and a square wave, which I'll talk about next. Square waves are essentially a true or false statement. This could be used for many things such as a send and receive technique, or maybe a trigger for a beat. Now finally, the saw wave, also called the sawtooth wave, which looks very similar to the triangle wave, however without the smooth drop-off. For example, this could be used for a riser. In VCV Rack, the most popular LFOs I use are the default VCV Rack LFO by VCV. No need to download anything there. Borg Audio's LFO allows a bit more control over the smoothness, offset and scale. Or the LFO from Surge XT, a very nice user interface showing a preview of the LFO and has a built-in envelope. Let's go into detail with the VCV Rack's built-in LFO. First, we see the frequency. This can depict how quickly the LFO goes from its lowest value to its highest value. The pulse width can only be noticed by using a square wave. The pulse width depicts how long the square wave will be open for. Moving down, we can see to the far right, this pulse width can also be modulated with another LFO if we wanted. The knobs at the top of these modulation inputs depicts how much the modulation can influence it. The buttons in the middle are an offset switch and invert switch. The offsets can either be bipolar or unipolar. To the left is a invert toggle, which can invert the signal. For example, if it was 10 volts, it will be negative 10 volts. Left again is the frequency modulation, which can modulate or change the frequency with another LFO or another module. Next, the click input can be connected to a clock module, which can sync your LFO wave to your setup or song. And lastly, the reset input can be used with a clock also, or some trigger module to reset the LFO to its beginning value. And the outputs are all at the bottom, releasing the different waves we talked about earlier. In conclusion, the primary function of an LFO is to modulate other parameters within the modular synthesizer. This could include modulating pitch, filter cutoff, or amplitude. or even modulating another modulator for more complex modulations, just meta modulation. LFOs can add much complexity to your patches and allows more control to your modules.